your 3 marks. If you set it up this way, you would give yourself like 1 mark for this one mark for that one, okay? With the limits of integration being exactly as they are on my paper. Okay, so that's part B. Now our last thing is part C. It says find when the particle is at rest. Things are at rest when V of t is equal to 0. So I would take 0 and set it equal to my function e to the sine of t minus 1. Then I would personally algebraically calculate this because I feel like it's pretty straightforward. But you could also just stick this in your calculator. So let me get rid of these absolute values. And then you could type, you don't even have to do that. Just calculate that, and it's going to draw the graph that we drew in number 1. And actually, honestly, if you did number 1 correctly, you would see that those two values happen to be at 0 and pi. You could calculate them on your calculator, though, again. So 0 seconds and t equals pi seconds. Okay, and that's going to be here and there. So it's 0 at 3.14, and this is by your calculator. This is the ugliest C ever created. So 0, 3.14. Okay, those are your two answers. You would get 1 mark for both of these answers being correct, and then 1 mark for your setup. Sorry. Okay, so there's that. Gemma's waking up. I think we have time to finish section A. Okay, yep, we do. All right, so then it says the graph of y equals x. Oh, let me get this out of the way because it makes it super hard to see. So the graph of y for the domain 0 to 5 pi over 2 is shown below. Part A says the graph has an x-intercept or has x-intercepts at 0, 1, pi, and k. Find k. Okay, so we would need to set our function equal to 0, but we're going to get a bunch of extra solutions. So we wouldn't want to necessarily algebraically do this because then we're just going to be solving for a ton of solutions that we don't really need. So what I would do is I would take our function x minus 1 sine x, set it equal to 0. Just set that in your calculator. You can clearly see that 0, 1, pi, and k are there in each of those places. So we would want to just like solve for the k. So we would have x minus 1 sine x. Oh, now I need my light back. So we're typing that into our calculator, graphing it, and I'm probably going to need to make my screen a lot bigger. So I want to go out to maybe 10. I'm going to go from negative 10 to 10 just because I don't know how low that goes. Okay, so here is, we have 1 at 0, 1 at 1, 1 at pi, and this one is at k. So we're looking for that 0 right there. So I want to make sure I'm to the left, then to the right, and then calculate that. And you get 6.28. You should recognize that this is 2 pi. So you can do this on your calculator. Okay, this is the k that we were looking for, and it should be 2 pi. You get 6.28. If you put 6.28, that's fine. I'll give you full credit for it. But I mean, just looking at this, 2 pi, sine of 2 pi is what gives you 0, and so you should recognize that. So you would get 1 point for setting up this equation, and plus 1 for your answer. And you could also have 6.28, and I would accept that. Okay. Then, oops, wrong cap. Then part B says write down an expression for V. Hold on. The shaded region is rotated 360 degrees around the x-axis, but V be the volume of the solid formed. Write down an expression for V. The shaded region specifically. So we're going to integrate the function given. And we want to square it. We want to put pi out front, and we're going from pi to 2 pi. That's our domain. And it's with respect to x. Okay, so our function for volume of x should be this. Okay, pi, this defines our radius squared from pi to 2 pi. And then don't go about this algebraically. Stick this in your calculator. So we would have pi times x minus 1 sine x, and then square it. And you would just graph it. Okay. And it's going to like, everything's positive now because we squared it. It flips it all up. And it's squared, so it's like extra big. And then we're going to second calc 7, the integral from pi to 2 pi. And it should give us our correct value, which should be, actually part B was just to set it up. Part C, we actually calculate it, and you should get 69.6 units cubed. You must have the units cubed to get full credit for that. Okay, so here you get +1 for the pi, +1 for both limits of integration. If you only got one correct, give yourself half. The pi and the square have to both be there to get that point. And then +1 also for the inside of this stuff. Okay. I feel like this could be better. Ooh. +1. Okay. And then you get +2 for your answer. If you did not have units cubed, give yourself only 1 mark. Okay. And I think I forgot to like keep doing this. This is out of 7 marks. You should be able to do this on your own, and I'll go back through and make sure they're all on each of the things. Okay, so that is paper 2, section A, problem 2, and we are almost done. So we will finish the last part in the next video.